talk about like machine learning inside containers. So how we bridge the gap between development and the production environment for the machine learning practitioners. So I'm Jingjing. I'm from TensorCore, and I'm the CTO and co-founder. So previously, I worked at AWS AI engineer. I majorly work on deep learning on graphs. So I'm the founding member and the core developer of Deep Graph Library project, which is a framework to help apply scientists to machine learning on the graph. And currently in TensorCore, we maintain 3 projects: envd, vector.rs. So we are an AI infra company, and we love open source very much. So our major projects are all. Hello. Oh. Okay. Our major projects are all open source and focusing on the AI infra. So you're welcome to check our GitHub repo, and we have and your side is welcome. And my GitHub account is VOV Allen, and yeah, I'm glad to speak here. Yeah, so today I'm going to talk about how to containerize your machine learning development environment by our tool called envd. So at the left side, it's our lovely logo. So we encode envd 4 letters into the logo. So E as the left face, and N and V as the mouse, and D as the right face. So everyone loves cats, so we made it as a cat logo. So the first question is like, why containers? So like why we think like container is a good tool for data scientists to use as their development environment. So here comes the questions that bothers data scientists a lot. The first one is like we found data scientists, they are hard to set up environments for different projects. The core reason is that in the machine learning area, Python and C++ are heavily used, and C++ library always have a chaotic dependency problem, and it become much worse even with CUDA. Like you need to do some computation on the GPU, and CUDA version, like with the deep learning framework version, becomes a nightmare for data scientists. It's hard for them to like set up isolated environments for different projects. And the second problem is like data scientists learn a lot about models, learn about math, learn a lot about algorithms, but like they know less about inference. So based on our investigation, we found that actually only some of the data scientists have heard of Docker, and only a small amount of them have used that. And it's very, very rare for the data scientist to actually know how to write a good Docker file to build a proper Docker image. So we've even seen like in some company, like their data scientists just do the Docker commits. So you just like do everything in the Docker, and you commit, and a layer over layer. So finally it becomes like 20 gigabytes image, and nobody know what's in that. So we think it's a pretty bad practice, like for everyone, or like for the data scientist, he doesn't know like what's actually in the environment, and for the company, like for a team, like they do not know is this image safe, or is there any security problem inside that? And the third problem is it's hard for data scientists to reproduce other people's work. So there are many new algorithm coming out every day. So the major work of scientists, they need to spend many time to reproduce others' work, and reproducibility is always a problem in the machine learning area. And we think a container is a good tool to improve this situation. Like if we make it easy to use and become a standard, like everyone can reproduce others' environments or works easily. So here's a figure shows the complexity of the Python ecosystem. So with only Python, usually on people's developed machine, such as macOS, you have multiple Python in your laptop, like the system built-in one, or the Homebrew Python, or there are a virtualenv or pyenv, and many times you don't know what's the actually Python you need. So you did pip install something, and it goes to the system building Python, and you find you can't find it in your Python 3. So we found it's quite common if you do everything on the host machine. And there are some existing solution for this, such as virtualenv, like pyenv or the Anaconda, but they majorly focus on the Python ecosystem, which is only the part of the problem. So here I listed something not included in the Python environment management tools. So you have some development tools which is not included in Python ecosystem, like some editor setting, and also a CUDA. There are complex CUDA dependency problem in the deep learning framework, such as PyTorch. There are many tools are binding to a certain version. So we think it's not enough. And also there are many more C++ library, such as OpenCV or OpenMMLab or MM detection. So there are many libraries that they are C++ and not included in the Python ecosystem. So we think containers is a better tool for the machine learning scientists to manage their project and development environments. So you can have a separate separate image for each of your projects. So no more chaotics. So how do we help machine learning scientists to containerize the development environments? So we've written CLI tools to help users to create the container-based environment for machine learning. So the syntax looks just Python. So it's actually a dialect of Python called Starlark, which is originally brought up by Google. So it's actually the language used in a Bazel building system, and we use them. We use it in our language, so user can use Python syntax to write their environment requirements. So and they are already familiar with the Python syntax, so it's easier for them to get on board for these tools. So you just define a build function and describe your environment need, such as the base operating system image, the CUDA version, and the package you need. And with that file, you just run envd up, and that's all. You will get into the containerized development environment like this. So you can see like it's already like Python, like the version, the latest version, and it will say, okay, you are in the envd environment. And the other like wonderful feature is that you can define many recipes of the common user tools. So here we use TensorBoard as an example. So envd lib is our like maintained recipe repository. So we provide many recipes for the common user tools. So you can directly call the tools like in envd lib to get it set up. So like for TensorBoard, you need to install the TensorBoard and set up it in the container. So without envd, you need like to change the entry point of the image, and that's only one part. So you might have multiple process need to run in the Docker simultaneously. So it will become complex if writing pure Docker file. And the third feature is also enabled by the Python syntax. So a common situation is that the production environment is slightly different from the development environment. So you want to include like dev tools as much as possible in the development, but want to remove that and minimize your production image as small as possible. So here, like the upper function defines the core dependency. Like you have some like Python package which is unified in both like dev and production. And in the dev image, you can declare more tools you needed. And for the serving image, like you can just remove them. So define something different, or like define the entry point so the serving image can be run like out of the box. Yeah, so I like to do a bit demo. Yeah, so here's like an empty folder with build.envd. So it's our custom extension name called envd. So I write a simple build function here. So it like defines the base, define a Python package. Like Via is just an empty package, like to do the demo. And we have the Jupyter notebook set up, and just call like envd. I think I already call that. I need first remove that, and I just do envd up. So it will start the building process and have everything installed. Because I've run the build process before, so you can see like everything is cached. So user will get the environment out of the box. So here I'm already in the envd environment in the container. So I can see the container here. So like here's the Python basic, and it will expose the port defined. And also we've embedded SSHD server inside the container, so you can easily use the environment on a remote machine, which is a common scenario for machine learning workers. So you usually develop a little bit on your own development machine, and then go to a powerful cluster with more powerful GPU. So we think like a remote development like SSH is needed. So we will add the entry to your SSH config file, so you can just do like SSH like Python basic.envd, and you can also get into the environment. Do this a little bit. Yeah. So. Yeah. So like, why not Dockerfile? Like, why we need to define our own build file format? So the first problem is we found like it's hard to reuse some part in the Dockerfile. So let's say you have some a library hard to install, like such as probably detection, or some like custom operator write by a PhD student. So it does not have a well distributed format. So you write once, but when you need to reuse that, you can just like copy paste from one Docker file to another. So finally, it will become a mess when you need to update those parts. And the second problem is we think the domain knowledge of Dockerfile is not like so suitable for the data scientists. So as I mentioned, like data scientists, they are good at algorithms, they are good at math, they are good at modeling. But for the Dockerfile part, it's more like infra. Like they do not have so much experience and time on that. So it's hard for them to write a good Dockerfile. And I would say like, it's also hard like for like other engineers to write a really good Dockerfile. There's many things to take into consideration, like how do you properly design the layers, and how to reuse the cache. So like you have two images, like want to install PyTorch, like how can you reuse the pip cache among them, and how like when you build the image, like how to use the files on host, and how to like run Jupyter notebooks like in the container, and also like how to like run the Jupyter notebook and the TensorFlow simultaneously in the container. Like they are all like real problem if you want to use a container as your development environment. So like we feel it's hard for the data scientists to use such tools. So we think like our Starlark based syntax is simpler and much familiar to the data scientists for them to use. And here's the internals of envd. So we heavily relies on the Buildkit. So Buildkit is actually the next generation build engine for Docker, I think. So it's actually a low-level build library to construct Docker images, and it's Dockerfile agnostic. So Dockerfile version 2 supports Buildkit, but you do not have to you use Dockerfile. Like any developer can define their own front-end language to use it. And another fantastic feature from Buildkit is that it supports parallel build. So in the Dockerfile version 1, you can only do like everything linearly. So one step must happens after the other step finished. But with Buildkit, you can parallelize different steps, so it overlaps the network I/O. So it can greatly accelerate it if you have some steps can overlap with each other. So then like you can merge two steps together later, which helps improve the build speed. And the third part is cache efficient. Like in Buildkit, it has a special design for the cache library. So you can easily share caches between different builds. So you have a different project using PyTorch, you can share the pip cache among those builds. But the point is Buildkit is very low level, so you need to redefine the interface for users. So here's an architecture of envd using Buildkit. So you have your project folder, and with an extra build.envd file is all you need for your environment from development to production. And inside envd, we have a Starlark language compilation to convert the envd file into our internal intermediate representation. And then we will convert it into the Buildkit LLB. So LLB stands for low-level build. It's like a representation inside Buildkit to construct the image. And when we finish the LLB construction, like we send it to the Buildkit daemon. So the daemon will handle everything about the build and produce an image. And finally, like it will send the image to the Docker daemon, so user can see the image inside like Docker PS, like as other image. So like we did some benchmark comparing to the Dockerfile. So we are faster than Dockerfile on the first build, like by about double the speed. So it is done by like we parallelize the Python install step and the apt install package step. So and we have other heuristic rules to parallelize users building script. And we've specialized. We also have specialized optimization for the rebuild. So it's very common for developers to change their development environment. So they might want to have some more packages immediately. So we specialize optimize for such scenarios. So it becomes about like I would say like 6 times faster than Dockerfile in the rebuild scenarios. And the other part like we support is about like a remote build. So user can like write the build.envd file locally and run the build on a remote machine. So we have a concept of context in envd. So you just create a new context like called remote build and specify the builder as a TCP address, and that's all. So it's also powered by the Buildkit. So this is pretty useful like when your build process needs lots of CPU resources. Like in some like machine learning workflow, you need to compile something from C++, like from the source code. You need lots of CPU resources, and also like the libraries in machine learning are pretty large, like TensorFlow or PyTorch. They are all gigabyte level, so you need good network bandwidth to make the build faster. So make it happens on the remote machine. Like you can put the remote machine in the public cloud. So everything will work as the same, but much faster because like a public cloud machine has larger network bandwidth, and also like you can give it more CPU cores. And for the developers, it can also like help them like improve their develop experience. So you do not have to run everything on your like Mac OS. So it feels bad like your machine like goes super hot and spend very long time to build the image. It's kind of a waste of time. So we found like remote build is a good feature, especially for the team CI/CD workflow. So you can like kind of like outsource the build process to a centralized machine. So it also makes the management of cache much easier. So you can reuse the cache as much as possible, like in your clusters. So here's the like the figure. Like so, you have CI/CD machine, and you do the context creator and use. So you can launch it from GitHub Action machine, like which has only like probably one core or two core, and to your dedicated build cluster. So and finally push it to the remote registry. Like everything just work like out of the box. So we feel like it can greatly also greatly reduce the CI/CD time, which is also the save of developers' time. Yeah, that's all my talk today, and thank you so much for being here, and also thanks to my colleague Ke Mian, like they help a lot on these slides and envd. And you're welcome to start us on the GitHub at Tensor Core organization. Like we have 3 projects now, like envd, as I just introduced. Open Model Z is like a framework to help developer to deploy models on the cluster. So it manage the engineering infra there. So you only need to add machine to the cluster and ask it to deploy models. And the third one is pgvector.rs. So it's and vector search extension on the Postgres. So you can directly do vector search inside the Postgres. Yeah, that's all. Thank you so much.